Alrighty, so today we are going to create scatter plots and describe the patterns from them, but our warm-up that we need to start out with is to determine if the following test grades have a high variability or low variability. So anytime you get a question asking you about high or low variability, what I'm really asking you to find is the mean absolute deviation. So we're going to go through the steps of how to find mean absolute deviation with this problem. So first step, we have to find the mean. Well, the mean is our average, so I'm going to take all of the test grades, add them up, and divide by 4. Make sure when you do this, the parts that you are adding go in parentheses. Otherwise, you will not get this number correct. So 82 plus 86 plus 91 plus 78. Add that all up, divide by 4. I get a mean of 84.25. Once you get the mean, the next step in finding the mean absolute deviation is to find the deviations from the mean. Remember, we're always going to subtract the data point we're given minus the mean. So the first data point we were given was 82. So 82 minus our mean of 84.25 gets me negative 2.25. 86 minus 84.25 is 1.75. 91 minus 84.25 is equal to 6.75. And 78 minus 84.25 is equal to negative 6.25. Step 3 is to find the absolute value of these deviations. So negative 2.25 becomes positive 2.25, 1.75 stays 1.75, 6.75 stays 6.75, and negative 6.25 becomes positive 6.25. Once I have the absolute value of the deviations, we're going to find the mean absolute deviation by taking all of those absolute deviations and finding the mean. So I'm going to add them all together again in parentheses to make sure that we don't make a mistake. So when I add 2.25 plus 1.75 plus 6.75 plus 6.25, I get 17. 17 divided by 4 gets me a mean absolute deviation of 4.25. Now, I've gone through all of these steps and I found the mean absolute deviation, but the question now stands on is it high variability or low variability? So low variability is when we have a low mean absolute deviation. Now 4.25 is less than 5. That is still a pretty low mean absolute deviation. So it's going to be low variability. Okay. You're checking your homework. All right, so we are now going to talk about scatter plots. So a scatter plot is a graph of points that shows a relationship. By analyzing data points, it can be determined that there is an association between two variables. Okay, so these are all blanks for you. I made them into a table, but you're just filling in the blanks, writing down these definitions. So the independent variable, we've gone over this a couple times before, it's the x. It's the variable that stands alone. And remember that time is always independent. So if you have anything that talks about time, whether it's seconds, minutes, hours, days, weeks, age, anything like that, anything that relates to time, we are going to talk about the independent variable. The dependent variable is your y value. It depends on the x. A lot of times your y value will be associated with a cost or something like that. It is whatever is dependent on the independent variable. An association is some kind of relationship between your independent and dependent variables. It's that relationship between x and y. So for example, if your independent variable is age, there is a relationship between your age and your height. So that would be an association. Linear association is when the points seem to form a line. The word linear says line in it. A cluster is a grouping of points in the line. And an outlier is a point that's not part of the cluster. It's kind of off on its own. It's like if you were talking about heights with a fifth grade class and you added Shaq. Well, all the fifth graders are going to be nowhere close to how tall Shaq is. And so that would be an outlier. So, different types of associations. So, the first graph on the left here, we're talking about a positive association because I read the graph the same way you read a book. You read from left to right. And if I go from left to right, these values seem to be increasing. So, the cluster is going up. X and Y are moving in the same direction. As X increases, Y is also increasing. So, they're both increasing together. Here, if you look at the middle graph, we seem to have a negative association because, again, as you read the graph from left to right, the points seem to be going down. And X and Y are moving in opposite directions. So as X is increasing, the Y values are actually decreasing. No association is basically when you just have a graph that you threw a bunch of points on the graph. So that is a no association. The data is scattered and does not form a pattern. So when we create a scatter plot, most of the time you're going to be given a table like this, and you're just going to be plotting points on a graph. So the table shows the ages and heights of 8 different students. Remember, we said time and anything that has to do with time is independent, and you can see that on our graph here that age is the X. So age is our an independent variable, and then our height is our dependent variable. So I'm just going to plot ordered pairs. I'm going to go 10 to 61, put a point. We have 11 and 64, 16 and 70, 11 and 63, 13 and 65, 15 and 70, 13 and 66, 15 and 67. Now you have to be really, really careful when plotting these points. You need to notice the scale here. So the scale, we are counting by halves because there's 4 spaces between 10 and 12. So 11 is here in the middle. And then over here, we're counting by ones, I believe. Nope. 63, 64, 65. Yeah, we're counting by ones on the y-axis. So just making sure you're paying attention to your scale when you're plotting points can be really crucial. Identify the independent and dependent variables. Well, we already kind of talked about that. The independent variable is our X, and we said time is always independent. So in this case, the independent is going to be your age in years. And your dependent variable is your Y, and that is your height in inches. So this is the exact same scatter plot that we just made, just on the next page. And it's asking you, is there a linear association between the age and height? Explain. So yes, the cluster goes up. It seems to form a line. The biggest point here we have when we're doing our data unit and we're talking about scatter plots is we are not having perfect lines. But does this shape kind of look like I could draw a line through it? Yes, I could probably draw a line and hit a decent number of points. So it is a linear association. Again, we're not going to be having perfect lines. It's just, does the general movement of the points form a line? In this case, it is. Is the association positive or negative? Well, if I look at the graph reading from left to right, I am increasing. So it's positive because both X and Y are increasing. And we're going to state the association in terms of the variables. This is the part where people make the most mistakes. When I ask you to state the association, I'm asking you to write a sentence that uses the independent and dependent variable in words. And how are they connected? Well, here's my sentence. As age increases, height increases. There's a sentence. I've written it out. Made sure to use what my independent variable was and what my dependent. I said age and height. You have to include those words when you state the association. So as age increases, height increases. Younger kids are shorter. That's another relationship between them. So what does the ordered pair 1061 mean? Well, I'm basically asking you again to state this value in terms of its scale, in terms of the variables that we're using for X and Y. So here, 1061, 10 is the X value, so that's the age. 61 is the height, which is the Y value. So I'm saying at 10 years old, the student was 61 inches tall. You need to be able to relate in words what the ordered pair means. So you're basically describing what the ordered pair means using the labels of the graph. So today we have a CFA on mean absolute deviation, and homework 3.3 is due on Monday.